You ever get annoyed why to put sunscreen on the beach? Well, maybe in this video, you'll find out why.
The second layer of the atmosphere, above the troposphere, is the stratosphere, which is commonly known for its ozone layer. The ozone layer is made up of abundance of three oxygen atoms, molecules, which protect us from UV radiation. The ozone molecules absorb the UV radiation and reduces the amount of UV radiation that reaches the surface. So without the ozone layer, life would be non-existent. The beginning of the stratosphere starts at the end of the tropopause. Unlike the troposphere, the stratosphere temperature increases with height due to absorption of UV radiation from ozone molecules that warms the air below. This creates an inversion layer, where warm air is above cooler air. Therefore, this layer of the atmosphere is stable and has very little vertical movement. Ozone concentrations peak at an altitude of approximately 25 kilometers, although the highest temperature in the stratosphere occurs at an altitude of approximately 50 kilometers. This is because the air is less dense at the top of the stratosphere, therefore the intensity of solar energy is greater on fewer air molecules. It is important to understand that the temperature is defined as the average kinetic energy of particles, and what animals and humans feel is the heat transfer from one body to another. At the top of the stratosphere is the stratopause, for which air remains constant with height.
The next atmospheric layer is the mesosphere layer, which is often forgotten like middle children. I would know I am one.
The mesosphere is known as the middle sphere of the atmosphere. In this atmospheric layer, meteors can be seen hurtling towards Earth, burning up and leaving a trail in the night sky. This is because the layer above the mesosphere are less dense, and then when the meteors pass through the mesosphere, there are often enough air molecules to cause friction and burn up the meteors. The air is very thin at this layer, and the atmospheric pressure is approximately 1 millibar, which is approximately 99.9% less than the air pressure experienced at sea level. The air temperature in the mesosphere decreases with height due to there being little ozone to absorb radiation energy. At the mesosphere, we find the lowest temperature in Earth's atmosphere near an altitude of approximately 85 kilometers, with an approximate average temperature of 90 degrees Celsius. Nitrogen and oxygen have the same percent composition as in the troposphere in the mesosphere, although the density in this layer is lower. Therefore, without a breathing apparatus, we could suffocate within minutes. Noctilucent clouds also occur in the mesosphere that are quite rare and would need the right conditions and time of day to be visible. Comment below on what your favorite clouds are. The thermosphere is commonly known as the upper atmosphere, where the aurora borealis and australis can sometimes be seen, and where the International Space Station orbits around the Earth. Comment below if you've seen an aurora before and what you think about it. The thermosphere is also water vapor and cloud free. In addition, most of the ionosphere is located in the thermosphere, which are electrically charged gas particles that bounce radio waves from Earth to around the world. The thermosphere is located at approximately an altitude of 80 kilometers and can reach an altitude of approximately 500 kilometers. The temperature in the thermosphere increases from the mesopause as the altitude increases. This is because the layer has low density and the oxygen atoms absorb intense solar radiation, although there aren't enough air molecules to transfer the heat for us to feel it. Therefore, our skin would still be cold if we were in this layer. The average distance of an air molecule would travel before it collides with another air molecule is 1 kilometer. For perspective, the average distance of an air molecule would travel to collide with another air molecule at Earth's surface is less than 1/1,000,000th of a centimeter. At an altitude of 500 kilometers, it would take approximately 10 kilometers for a molecule will collide with each other.
The last atmospheric layer we're going to talk about is the exosphere, where flat earthers think that dome exists.
The exosphere represents the outermost layer of the atmosphere, which can extend from the thermopause to approximately 10,000 kilometers. At this altitude, particles and molecules can shoot up into space, and this is where most of the satellites orbit.
If you missed part 1 of the atmospheric layers, see it up here. Thank you for watching. Please subscribe. If there's other videos you'd like to see in the future, please let me know.